Alrighty, welcome to lesson 2.4, where we're going to talk about more linear problems. In the practice questions, you'll find problems on perimeter, midpoints, and linear measurements. Remember, linear just means line. So this means we're just dealing with different length problems. We're going to focus on a couple kind of more in the perimeter area. Alright, since we already talked about those before. So I'm just going to do two examples for you. The first example. Bill's front door has a semicircular window, like the one in the photo. The base has a length of 60 centimeters. And I'm going to calculate the perimeter of the window. So all we know is this length right here. So we know that the perimeter will equal, well, that bottom side plus whatever this is, plus that kind of frown. So we just got to figure out what that frowny shape is. So first off, we are just going to do a little bit of imagining. What did I just do? A little bit of imagining. Why won't you move? Wrong thing. Alright, anyway. Let's just picture that this is a full circle. Alright, I know how to find the circumference of a full circle. Circumference is just pi times diameter. So if I can find the circumference of the full circle, I can just cut it in half to figure it out for that frowny shape, that semicircle. Alright, so let's figure it out for the full circle. So circumference equals pi times diameter. My diameter is 60 centimeters. So let's just figure out that length there. So pi times 60 equals, bam, 188.49. Let's just call it 188.5. 188.5 centimeters. But that was for the full circle. So my frowny shape was that distance divided by 2. So I only want half the circle. Alright, so I'm just going to take that number divided by 2. Alright, actually, I'm going to redo that. So 188.5 divided by 2 gives me 94.25. So my frowny face is 94.25 centimeters. So my semicircle, so including the bottom piece, is equal to 94.25 plus that bottom piece, which was 60. Alright, so I'm just going to go back to my calculator. Whoops, not bad. Go back to my calculator and tack on another 60 centimeters. That gives me 154.25. So my perimeter of this thing is 154.25 centimeters. Ready? So as you've seen, the trick for these shapes that we don't have formulas for is to break it up into shapes that you do know. Alright, I cannot stress that enough. Break it up into shapes that you do know how to deal with, and then go from there. As we can see in the next problem. This one's a little bit trickier. So the following diagram shows the layout of a running track. The ends are semicircles with a diameter of 50, as you can see here, and the perimeter of the track is 400 meters. I want to know what the length of the straight side is here. So I know the full distance is 400. So I want us to just take a look at this. This is a semicircle here, and this is a semicircle here. If we were to break this down, actually, let's just put that back for a second. The full track also has that straight side that we're looking for, and another straight side that we're looking for. So the perimeter of this thing is equal to one semicircle plus a straight side plus a semicircle plus a straight side. Now if we rearrange this, I just drag this down. Let's just move that up, sure. You can see that I have a circle and two lines. Come on, line. There, come with me. There we go. A circle and two lines. So my perimeter equals a circle plus a line. Oh, let's just say two lines. Or that's a circle, not a zero. So let's just use this as our formula. So I already know that the perimeter is 400 plus, equals, and instead of line, I'm going to switch to the letter. We said that each line was D. So 400 equals the distance around my circle plus 2D. Now the distance around the circle, we know that is the circumference. So equals the circumference of that circle plus two diameters. Now we just got to figure out what the circumference is, and then we can figure this part out. So let's do that separately. You don't have to, but let's do that. So I'm just going to erase this here. So my circumference, I know that the formula for circumference is 2 times diameter. Not this d, the diameter of the circle, which we knew was 50. 2 times 50, I can do that one in my head. That is 100. So my circumference is 100. So I can put that in right here. So 400 is now equal to 100 plus 2 of those straight distances. Now I can work with this to try to get that d by itself, get that distance by itself. Alright, so I need to, we'll kind of work from the outside in. First I got to deal with that 100. We're trying to get this by itself. So I need to undo the plussing of 100. So I'm going to subtract 100. But whatever I do to one side, I got to do to the other. So 400 minus 100 is 300. 100 minus 100, that's just 0. So all I have left on the other side is 2 times d. Alright, I'm going to just move over here. This is all separate. So 300 equals 2 times d. So now I just have to undo that multiplication. The opposite of multiplication is division. I'm trying to get rid of the 2, so that's what I'm dividing by. Again, whatever you do to one side, you do to the other. Remember, that's one of those math laws. You break the math law, you go to math prison where they do bad math things to you. You don't want that. So, you got a 2 up top, 2 on the bottom, they cancel out. All you got left on the other side is the d. Now, you got on this side 300 divided by 2. That's 150. Ta-da! There's my answer. I got d by itself. Alright, so that distance there is 150 meters. Sweet. Alrighty, now you have a bunch of fun examples like this that are using shapes that aren't, I guess, normal, if you would. Alright, so remember, break it down into shapes that you know and work from there. Okay, try these out, ask questions if you have them, and make sure you check your answers after. Have fun with these.